Hello, everyone. Thanks again for joining us. I'm Jen Weesey, and I will be your moderator for today's webinar. And I work with the Girls and Micronaut team here at Object Computing. So, like I said, thank you again for joining us. We are so excited to have two presenters today on this webinar. We've got Sergio, who's joining us live from Spain. And Sergio is one of the core members of the Girls and Micronaut team here at Object Computing. And we have a special guest with us today, Stefano Giuliani, who works with Amazon. And he and Sergio are going to be talking to us today about Micronaut and AWS and how great they are working together to help us superpower our apps. And with that, I'll pass it over to you, Sergio.
Thank you, Jen. Thanks everyone for joining us. Thanks, Stefano, especially for joining us. I will let Stefano introduce himself, but he's working for AWS for the serverless part, so he's probably the best person to talk to us about the state of AWS, Lambda, and Java. I want to cover a couple of things, only the agenda before I let Stefano tell us about AWS, Lambda, and Java. So first part of the presentation is going to be about that. Then we are going to discuss how to distribute Micronaut applications to another AWS service such as Elastic Beanstalk, a couple of tips and tricks. Then we are going to see how to set up a CI and CD pipeline using some of the AWS developer tools such as Code Commit, Code Build, and Code Pipeline. We are going to see a couple of the most usual things that we often have to do as developers in an application, such as sending emails or uploading and saving files. And then I'm going to show you Micronaut 12.2 module integration with AWS Cognito, which is an identity service from Amazon, which will basically offload a lot of your developments. You will not have to cover about user registration, password reset, etc. So with that said, the floor is yours, Stefano.
Thank you, Sergio. Hi, everyone. Thank you for having me on this webinar. I'm going to talk about writing Java application in AWS Lambda. If you're not familiar with AWS Lambda, it's our highest abstraction compute service. With Lambda, you only have to give us the code that runs your business logic, and AWS takes care of the underlying infrastructure, the operating system in the virtual machine, as well as the language runtime, the JVM in this case. Lambda functions run in response to events. An event could be a file being uploaded to S3, some new data arriving in a Kinesis stream, or, as in the case for this webinar, an HTTP request hitting a service such as API Gateway or the application load balancer. Because of this model, Lambda charges you only for when your code is actually executing in increments of 100 milliseconds. That means that if you receive no events, no requests, you pay 0. Now, with that out of the way, Sergio, can we go to the next slide? We recently announced support for the Java 11 runtime inside Lambda. A lot of our enterprise customers had been migrating to Java 11, so we decided to include native support for this runtime. Having said that, we launched a few features over the past year that allow you to run any language inside AWS Lambda, and we'll go through those later. Another note on this, on the next slide, Sergio, is that if you're interested in the tips I'll share today and you want to dive deeper on these, and you also happen to be attending reInvent, we have a session dedicated specifically to Java in Lambda, where we'll cover Micronaut as well. It's called Best Practices for AWS Lambda and Java, and if you're searching for it in the reInvent catalog, look for SVS 403. Now let's talk about Lambda. Let's go to the next slide, Sergio. If you have worked with Java and Lambda, you're most certainly familiar with cold starts. Because of the execution model of Lambda, where we spin up infrastructure on demand as events arrive, you experience a slower startup time on the first event, because that's when we allocate the infrastructure, download your code, spin up the environment, and start it. This is what we call a cold start. Once we have spinned up an environment, we'll try to reuse it as much as possible for a period of time. So now that this is out of the way, and as I said, if you're familiar, if you've worked with Lambda before, you will be familiar with cold starts, particularly for Java. Next slide. Let me tell you what happens during a cold start inside Lambda. First is that Lambda will start a JVM, and the JVM will load the Lambda runtime. The Lambda runtime is just a small collection of classes. All they do is go and find the class you have configured as your event handler, create a singleton instance of that object, and then call the handler method. In this slide, you can see a screenshot from the AWS X-Ray console. X-Ray is our distributed tracing system, and it gives you a nice breakdown of the execution of a Lambda function. If you look at that diagram, the first 100 milliseconds where there's no bar is the JVM itself starting. Then we get to the initialization step that is highlighted here. The initialization step is when the Lambda runtime itself loads your class and creates the singleton instance of that object. And then we get to the invocation step, which is when we actually call your handler method to handle an event. In this particular case, you see that the initialization step was pretty long. It was about 2.5 seconds, 2.8 seconds. And that is because in my example, I was doing a lot of work in the constructor of my handler class. And I did that on purpose, because what you need to know is that behind the scenes, during steps 1 and 2, as we start the JVM and initialize your handler class, you have access to more of the host CPU than you do when we call your invocation, your handler method. And so I was front loading a lot of the work during that initialization step to speed up the invocation step. To give you a measure, I took some code out of the handler method from the invocation step and moved it to the constructor. And what used to take at seconds in the invocation step only took 2 seconds in the initialization. So I decided to make that trade-off. If we can go to the next slide. What you need to keep in mind as well is that Lambda function allocates an amount of CPU that is proportional to the amount of memory you've configured for the function. So if you have a CPU intensive function, then you'll be better off allocating more memory. In fact, giving it more memory and more CPU may cost you less, because the speed up you get may more than double what it was before. You have to keep in mind, however, that more memory means more money. There is a open source utility called Lambda Power Tuning that will run your function at all possible memory configuration and then generate a report telling you what is your best bet between cost and performance. So if that's something you're interested in, you should take a look at it. Let's go to the next slide. Now, cold start is a well-publicized problem, particularly for Java developers using Lambda. However, I would argue that in the future, as we try to get more and more utilizations out of our infrastructure in general, the same will become true for containerized applications. We need your container to start fast as you handle a traffic spike, because this will allow you to handle more requests with fewer containers and leave more capacity available for other applications. Let's go to the next slide now, and we can get into the more practical tips. So the first thing is front load the classes, objects, metadata that you know you will need during every single invocation. That's what I was doing in my example. That's why my initialization step was longer. But by doing that, you take advantage of that higher CPU access during the initialization step. This is particularly true for libraries that rely heavily on reflection, such as Jackson, as well as code that needs to connect to external services. You'll see a significant improvement in the TLS handshake time by making a request during that initialization step. Now, my next point is to try and avoid reflection. Over the past 2 decades, I would say, we've become heavily reliant on reflection in the Java world. And don't get me wrong, reflection is an extremely powerful tool. However, it is also very CPU and IO and memory intensive. It was thought for a world where the start time didn't matter. All we cared about was the runtime execution. Today, when our software needs to start quickly, reflection is not the right tool for the job very often. If you want to dive deeper on this, like I said, I will have a reInvent session, but if you're interested in, you can just search for method accessors and specifically the native method accessor and generated method accessor implementations. There's lots of good information out there telling you how these work and why they are CPU and memory intensive. On top of that, including a lot of dependencies and classes in your package will mean that class path scanning as you try to load a class will become slower and slower. And that is definitely not ideal in a resource constrained environment such as AWS Lambda. So my recommendation is, as much as you can, try to take dependencies on libraries that avoid reflection. Libraries such as Micronaut, as well as Dagger 2 for dependency injection. And Jackson itself has published the Jackson Junior version of the library that is much faster than the traditional object mapper in Jackson. The next is to switch to the AWS for Java v2. The AWS SDK for Java is a complex piece of software and used to be a very big library. After we released Lambda, the AWS SDK team worked on a v2 of the Java SDK that gives you a number of benefits. First is modular. You can include just the bits you need of the SDK. You don't need to bring in the whole giant package. Second, it gives you the ability to pick the HTTP client you want the SDK to use. The V1 SDK used the Apache HTTP client, which is a large piece of software in and of itself. With the SDK v2, you can pick between the Apache HTTP client, the Netty non-blocking IO HTTP client, as well as the good old URL connection HTTP client. And I would argue that for Lambda, the URL connection client is more often the right choice, because Lambda itself will force that each environment only processes one event at a time. So you're unlikely to need significant IO capacity as you make HTTP requests, because you'll only be processing one event. On top of that, I always advise customers to provide all of the known configuration values and to avoid auto-discovery. The AWS SDK is a good example of this. By default, when you initialize a service client, let's say a DynamoDB client, and you don't provide any parameters to the constructor, the AWS SDK will do quite a bit of work to first parse a very large JSON file that contains all our service endpoints in each region to find the endpoint you need. Then it will go through all of the possible credential provider implementations. They could be in a configuration file, they could be environment variables. If you are deploying that software, you know the environment you're deploying to, which means you know all of those parameters. You could, for example, place them in environment variables yourself and then provide them to the SDK yourself so that you avoid having to do all of that default auto-discovery. Can we go to the next slide, Sergio? Thank you. Now, a much higher level point, and something I try to do with Java developers a lot, is that if we want Java to work well in Lambda, we need to change the way we write Java code, or at least the way we think about the architecture of our application. We are heavy Java users ourselves at Amazon, and very often I see developers creating interfaces for classes that will only have one implementation. If that is the case, then you probably don't need that interface. You can just write the class. And even if your answer to the question is, maybe a few years down the line, there will be a second implementation, worry about it a few years down the line. You don't need the interface. Same story for builders. Java developers start loving builder classes. However, I've seen a few builders for classes that have a single parameter to their constructor. In that case, you don't really need a builder. Try and slim down your code as much as you can, because more classes to load potentially means more work when you do class path scanning, more memory consumed. The second tip is to remove dependencies you don't need. When Lambda starts, it needs to download your code. So the larger that package is, the more dependencies you have in there, the slower that start time will be. And this includes using tools that are provided with Maven and Gradle to exclude dependencies that you only require a compile time from the deployment package. And finally, if you need to prime those dependencies, I'll give you a practical example of this. In my sample application, I was initializing a DynamoDB client in the constructor of my handler class. And then as the handler method itself started, I was making a request to Dynamo. Because the AWS SDK lazily loads its components, it was starting the object mappers to serialize and deserialize requests and responses from Dynamo inside my handler method. And that meant that it was doing it while I had less CPU access than I did during the initialization step. And so I did a kind of a hacky thing around it where in my constructor or in a static initialization block, I made a request to Dynamo that I knew would fail. However, that forced the SDK to exercise all its marshallers. That means creating all the object mappers, doing all of the reflection at that time, and then allowing Jackson to cache that information at that point, so that by the time I got to my handler method, the execution was very, very fast. Now, at this point, we have a quick demo that I recorded. A lot of our customers use Spring Boot to create applications with Java. And Micronaut allows you to take a Spring Boot application, natively supports Spring annotations, and compile it with GraalVM as a native executable. If you're not familiar with GraalVM, it's an Oracle open source project. It's a polyglot virtual machine that allows you to run multiple languages inside one virtual machine and allows communication between the different languages. However, more important for Java developers working with Lambda, it enables ahead of time compilation of Java code to a native executable. And this works really well with the Micronaut framework, because Micronaut takes care of eliminating reflection and generating all of the configuration and code that is required at compile time. To make this run inside Lambda, we take advantage of a couple of features in Amazon API Gateway and AWS Lambda. The first is proxy integrations. If you have worked with Lambda and API Gateway or the application load balancer, you will be familiar with this. API Gateway receives a request and automatically generates an event object that contains all of the information about the request. Micronaut takes care of receiving that event for you, transforming it into an HTTP request, and passing it to your code. That means that you can use the exact same code base, whether you're running in Lambda or whether you're running in a container or in Elastic Beanstalk or EC2. That is a very, very powerful feature. Now, how do we pass these events inside Lambda? Because a native executable runs in what we call a provided runtime. If you can go to the next slide, Sergio. We use the runtime APIs, something we launched last year. And that is what allows us to support any programming language inside Lambda. When you specify that you want to use a provided runtime, Lambda simply expects you to have an executable file called bootstrap in your deployment package, and then exposes a small HTTP endpoint inside your environment that you can pull to get the next event and you can push responses to. This is what the Micronaut framework does for you behind the scenes so that you can run the exact same code base. Now let's take a look at how this runs. And if you remember, the sample application I had at the beginning of the slides took about 5 seconds to cold start. You can start the video, Sergio. Excellent. This is my pet store sample. It's a classic pet store. And as you can see, it uses Spring Boot annotations. It's a standard Spring Boot application, except that I use Micronaut to run it. I use the classic request mapping annotations, Rust controllers, as well as auto-wired beans. I have some configuration beans that this class loads and includes. So as far as you're concerned, if you do use Spring, nothing has changed. Where the magic really comes in here is in the build process. If you look at this build Gradle, the project itself inherits from the standard Spring Boot application project. However, in the dependencies section, all of the annotation processors are coming from the Micronaut framework. And that is where Micronaut goes and finds both the Micronaut annotations as well as the Spring Boot ones and generates the code and configuration instead of relying on reflection like Spring Boot would. We then use Docker to build a native executable because we need to build it for the correct target platform for Lambda. My build script simply runs Gradle, just like you would, to generate a fat jar. And then we run that Docker image. That Docker image uses the Amazon Linux version that Lambda itself runs and has GraalVM pre-installed and ready to go. The GraalVM build script is very, very simple. It uses the native image tool that GraalVM provides to perform the ahead-of-time compilation of the fat jar. The output of this will be an executable file. So let me go into my development box here and start that Docker build script just like you would. You can see that I've run Gradle build, and this will generate the fat jar. The fat jar is something I can use already if I wanted to, and deploy it inside Lambda in the provided runtime running in the JVM. The next step, this step, is the GraalVM compilation. I've speeded up the video slightly because it's hard to talk for 50 seconds while we look at a screen that has just some text on it. But I would argue that the speed gains we get from compiling in advance in cold start are by far outweigh the 2 minutes compilation time it takes. So next, I'm using CloudFormation to deploy the compiled executable to Lambda. I have a serverless application model package. The package command uploads my code to S3, and the deploy command calls CloudFormation to create my stack. Once CloudFormation has deployed the stack, unfortunately, it's a recorded video, so I cannot increase the font size, but I promise I will post the video on YouTube afterwards. So now I just describe the stack to get the output URL. This is the URL that was generated for my API, and then I use curl to call it. And as you can see, this was a cold start of a brand new application, Spring Boot application, and the latency as perceived from the client was 700 milliseconds. That means the entire cold start inside Lambda took about 500 milliseconds. So I would argue that that is the future we're going towards, and Micronaut make this extremely easy. If you want to take a look at that example, is on the serverless Java container GitHub repository. So you could replicate this process yourself. All the instructions are there. And with that, back to Sergio.
Thank you, Stefano. I have a link to the to Stefano code sample, which is the first one, which is the pet store using Spring annotations and doing the compilation using Micronaut annotation processors. I have the same sample as well using just regular Micronaut applications, which is also a standard annotation such as @inject. I have two samples, one with the same code, not generating a native image, but using the API gateway proxy to Lambda feature of AWS, which I think is game changers for Lambda development, because it allows to create really complex Lambdas where you have multiple endpoints, where you can have really logic as we are used to develop and deploy to EC2 machines, but deploy them in Lambdas. And then I have the same sample, but using the custom runtime, as Stefano was mentioning. So if anyone is interested, check them out. We are going to be publishing a lot of content in guides.micronaut.io around the AWS Lambda Micronaut, so stay tuned for that. And you should be able to follow along with the step-by-step instructions. So right now, just to wrap up the Lambda section, we have 4 ways to basically create a function with Micronaut and deploy it to AWS Lambda. One is to have, if you have like a single function, by that I mean you just need a Lambda which only is going to take like one endpoint, and you want to, maybe you are going to receive a Pojo, do something with the Pojo, and then respond a Pojo back. You have two opportunities there. You can either use the add function bin annotation, or you can implement the function initializer. The differences here are function bin will allow you to use like custom Jackson modules, while function initializer will delegate the marshalling and unmarshalling to AWS. So if you don't need any Jackson specific logic, function initializer will be probably the best approach, because it will be slightly faster than the other way. Then, and probably the most interesting thing is if you want to generate your regular app as you are used to with controllers and add, get, add, post annotations, you will want to use the API Gateway Lambda proxy integration. We have 2 dependencies and 2 features which go by the same name, which will allow you first to use the API Gateway proxy functionality, and the second one will allow you to create a custom runtime. So we have written a custom runtime so that you can use with your Micronaut Lambda applications. So that's ready out of the box for you. So we encourage everyone to check it out, because we believe Micronaut is a perfect fit for AWS Lambda. And with this, I close the Lambda part of this webinar. AWS has a lot of services, and they keep adding more and more. We're going to talk only about a couple of them, some that you probably will encounter if you work with Java, AWS, and Micronaut. So the first one I want to talk to you about is Elastic Beanstalk. Elastic Beanstalk is arguably the first service that you will interact with if you are a Java developer and you start your journey in AWS. I like to think of it as an abstraction above AWS services. It basically allows you to set up a load balancer, multiple EC2 machines where your jar file will be distributed to. It also even allows you directly from the wizard of Elastic Beanstalk to create a database, an RDS database. Allows you to tweak several configurations, such as configure a health endpoint so that you can be notified if your application is having troubles. You can configure the policy for auto scaling, etc., etc. So it's a nice abstraction on top of other services. It's free to use. The only thing that you will be charged for is the services that it creates. So you will be charged for the EC2 machines or the RDS databases that you create, but the Elastic Beanstalk itself it's free. Basically works, you create an application and it supports multiple environments. So typically, you may have like a production environment, and then you will have like a staging environment. that works in Elastic Beanstalk out of the box. Actually, it's pretty simple to configure it. For distributing a fat jar, a Micronaut application, you will typically select the web server environment. You will say that you want to use the Java platform, and you will upload your jar file. So if Micronaut is build agnostic, you can either use Maven or Gradle. If you are using Gradle, we configure the Shadow Jar Gradle plugin, which exposes a Gradle task called Shadow Jar. If you execute Gradle wrapper Shadow Jar, that will generate under build libs folder, it will generate a fat jar that you can deploy directly to Elastic Beanstalk. By default, Elastic Beanstalk expects your application to start import 5000. By default, Micronaut applications start import 8080. Because of that, you will need to configure via an environment variable that you want Micronaut to start import 5000. That's simple enough to do in Elastic Beanstalk because they have like a section to basically supply environment variables. And as I am showing here in this slide, is just one change to be aware of. This is more or less a typical scenario that you will have when you deploy a Micronaut application to Elastic Beanstalk. You probably will, it's not required to use a load balancer, but chances are that you may want to have a load balancer if you have a significant amount of traffic. And you probably will have multiple EC2 instances where your application is distributed to. And those instances may communicate with a single database or maybe with a database with replica instances as well. So that depends, but the typical scenario will be like multiple EC2 machines behind the load balancer. And in those cases, you will find a couple of tricky scenarios, which are really simple to work with once you know what's going on, but that may surprise you. If you want to, for example, retrieve the IP address of the person accessing your application. So if someone comes to your app.com in their browser, there will be IP 124, but when they hit the load balancer will have its own IP, and that's the IP that you will see in your request when you receive it. However, Amazon will create additional HTTP headers and will create one HTTP header, which is more or less an industry standard, which is the X forwarded 4 HTTP header, which will include the original IP address used in the request. So just remember, if you want to use the IP address, just access the HTTP headers. So you can, in a controller in Micronaut, you can bind an HTTP header object, or you can always do request dot headers, get a name, and you can see that. Or what I recommend you is just when you deploy your app, create a controller which logs all the HTTP headers so that you know what's available for you. Another typical scenario is you use the Amazon Route 53 service to basically configure your domain DNS, and you purchase a certificate from AWS Certificate Manager, and you point the certificate and the domain to Elastic Beanstalk. So you actually are serving an HTTPS semicolon -- myapp.com, and you want to in your application you want to resolve the host. So you want to resolve the actual real address that the user input in his browser, and we ship with a functionality called HTTP host resolver, which will use these X HTTP headers to resolve that. So it's a simple bin that you can inject in any other bin. And it has a single method called resolve. You pass the request and it will basically attempt to resolve the host in several ways. And that will basically take care of allowing you to retrieve the domain. For example, if you are deploying your app in Elastic Beanstalk and you want to use that domain, for example, to populate an email transactional template or something like Another really cool thing is with Elastic Beanstalk is to tell Elastic Beanstalk where your health endpoint is, and Elastic Beanstalk will keep polling that endpoint every 5 seconds. And if the endpoint returns anything that is not 200, then you have an alert. You can configure it to send you an email address, to send you an email or different notifications. So that's really easy. You can say, okay, my application has the health endpoint under health. And then you have to turn on the health endpoint. So if you are, so Micronaut endpoints are similar to Spring Boot actuators. So it's basically some endpoints that you can turn on easily. So in order to turn the health endpoint, you have to include the Micronaut management dependency. And then you turn on the health endpoint on, and then whether you want it to be sensitive or not, that depends if you turn on security. But basically, by default, you will expose really little information, so it's probably not harmful to have the health endpoint open. So that would be the configuration to do that. That wraps up for the Elastic Beanstalk. I want to talk to you about code commit. And basically, I want to talk to you about creating a continuous integration pipeline and a continuous delivery pipeline. Code commit is a code repository service. It's basically I would like to think about it as private Git repositories, which have one cool thing, which is they secure the data in transit and at rest. Is similar to a GitHub or a Bitbucket or any of those services. It's a completely optional service in these pipelines that I'm going to show you. But this is one service that is available. If you want to use GitHub and use the other services, that's completely possible, and actually is really well supported in the AWS console. So don't be afraid if you don't want to use code commit. But if you want, and I use for some of my projects, that's a really nice way to have like private repositories and with features such as pull request, etc., etc. So in your app, it will be like a regular Git origin. So nothing fancy here. The more interesting service here is code build. Code build is the continuous integration service of AWS, similar to Travis or Circle CI or now GitHub Actions. So it's a service along those lines. Then they have another service which I'm not going to cover in this webinar called Code Deploy. And then they have the fourth one in this set of developer tools, which is the orchestrator, which is AWS pipeline. It will allow you to create pipelines by combining code commit, code build, and code deploy. Or if your deployment is simple, as is going to be in our case, because we are going to just basically pass the fat jar to Elastic Beanstalk, you can just use the combo of code commit, code build without even using a code deploy service. So let's imagine in your company you want to create this structure. You have one repo. You are going to tell your developers you can code fast and loose against develop branch. Whenever you push code against develop, this is going to run all the tests and it's going to put the test reports in an S3 bucket, because as we all developers know, whenever the build breaks in CI, it's sometimes tough to understand why it broke, and sometimes being able to check the test reports where the standard output logs are safe, that's always helpful. So creating such a continuous integration pipeline with code build will require you to have a build spec file. So by code build supports multiple build specs. By default, it expects the build spec.yaml file. It has several phases. First phase, if you are working with Micronaut, is you will have to use Java runtime. You can use OpenJDK 8 as I'm using in this example. You can also use the AWS Java distributions. Corretto is supported. Then you will tell the commands. You will tell, here I'm telling just run the test with build scan. I have these things highlighted in red. That's used for basically speeding my Gradle builds. I am caching some of the artifacts that Gradle will generate. And the thing highlighted in yellow is basically where I tell when you run tests in a Micronaut app, by default, the reports will be placed in build reports test. So I'm telling pick those files, and those are my artifacts. So really simple to do. Imagine if for the develop branch, you don't deploy, but for the master branch, you want to deploy to Elastic Beanstalk. Whenever something is merged into master, maybe you even lock down master and there is only one person who can merge to master. You want automatically to trigger a deployment to Elastic Beanstalk. So similar scenario to the previous one, just one extra step. In pipeline, they will visualize the pipeline with a nice interface where you see like source, build, and then deploy. Here, my last step is deploy to Elastic Beanstalk. You basically tell if you are deploying to Elastic Beanstalk, you just have to choose, okay, you have to tell, I want to deploy to this application in this particular environment. And my source is going to be this output from the build task. So in order to generate a fat jar in Micronaut, really easy. If you are using Gradle, you just run shadow jar, which is what I'm doing. That will generate under build libs folder a file with the structure such as my app 0.1 that's all.jar. So that's what I'm doing. I'm picking that, and I'm flagging that's my artifact. I showed you before that I was using Gradle cache, and that will improve your code build builds a lot. And code build will charge you by the minute. So the faster your builds will probably improve your developer productivity because they will not have to be waiting for a build to complete, but it will also improve your pockets because it will cost you less money. So what do you need to do? You have to configure what do you want to cache under in build spec, and also you have to enable Gradle caching as well. So I am enable Gradle caching by setting org.gradle.caching equals true in my Gradle properties files. I will be automatically picked by Gradle. I am showing here you a screenshot of Gradle build scan where it says that I hit the cache, and he didn't need to generate those outputs because those outputs were already in the cache. So I showed you in the previous slide a screenshot of a Gradle scan. Gradle scan is one really cool thing from Gradle. Gradle scan is free. They have like a product called Gradle Enterprise to like aggregate the scans and give you other information and other capabilities. But Gradle scans are free. You can benefit just by adding the Gradle scan plugin. You will have to accept the terms of service manually, like every time you invoke a build, or you can add like a block, such as the one that I added here in the slide, where it says, I agree to the term of service. And then you pass the argument dash scan, and that will basically generate a scan, which is a public URL, which gives you information like which parts of your build are slower. It will allow you to flag like if you are doing too much work in the configuration phase, which we shouldn't be doing. It will also give you information about which tests are the slowest. It will allow you to basically improve the speed of your builds, and that will be key in order for you to maintain productivity. So really easy to set up build scans in CodeBuild. With that part, I am wrapping the continuous integration, continuous delivery part. I want to talk to you about Amazon simple email service. This will allow you to do something that we all do when we are developing applications, which is we need to send emails, right? So Amazon has one transactional email service in the platform. This is similar to products in the space such as SendGrid. The people from MailChimp used to have a product called Mandrill, which they have shut down, or at least I think it's shut down. So it's a similar in the space. You can send both text and HTML emails. you will need to verify that you are the owner of the domain that is sending the emails. And I think you will need to verify as well, if I recall correctly, I needed to verify the sender email address as well. And you have to configure a couple of things like to an endpoint to receive, like if you have bounces. So they have like some tooling around that you need to implement in order to deal with so that you are not like a spammer, which is great. And they have those capabilities. From a day-to-day, sending an email is simple. As Stefano recommended before, AWS SDK version for Java version 2, it's probably the way to go. The Maven coordinates have changed. Coolest thing is you can only include the services that you need to use. So here I'm including only the simple email service dependency. I am creating an interface to encapsulate my configuration. This has basically defines the region that is going to be used for simple email service, the source, that's going to be who is the person sending the email, and the destination. The destination in your application may come from a column in the database. In this example that I put together, this is simply like a typical email service that you may have like in an application which every night sends an email about, I don't know, the number of sales in the platform or something like that. So this is an email where we know in advance both sender and recipient. I have a configuration properties. Configuration properties in Micronaut allow you to, so I am using here, you see this not blank annotation, so they allow you to basically use validation constraints to ensure that you don't forget to add this configuration. And they allow you to define like a prefix, and they will take care of binding the configuration that you define in application.yaml to this object, and this will create a bin of type simple email service configuration. So in application.yaml, you will have something like this, where you have a region. So I am based in Madrid, so that's the closest AWS region to where I live is Ireland. So that is a US one. And yeah, two email addresses, my OCI email address, my personal address. Really nice thing about AWS SDK 2 is really simple to deal with AWS credentials. So there are this piece of code that is highlighted. This will initialize a simple email service client. It will use the region that I had in configuration, and it will try to search if you have an environment variable, if you have environment variables with your access key ID and your secret key, will use those. If those are not present, then we will try to use system properties for those. If those are not present, it will try to use, and that's the recommended approach, an IMN role with a policy that supports that your application is sending emails. So if you use this thing and you are using IMN roles with policies, which is the recommended approach, you will no longer have to have like access keys ID and secret keys ID flying around with the security risk that entails. Then if you see here the send email method, that's you see it has a builder API where you can configure like multiple destinations. You can also configure whether you want to send HTML or plain text, as I'm sending here. So it seems verbose, but it's powerful and pretty simple to send an email. This is an example of an email being sent via Amazon. Nothing complicated, and if you are already in AWS, this is personally what I use. It's really cheap as well. Simple cloud storage, one of the oldest Amazon services. This is all about saving files and retrieving files, updating files. So basically, when you deal with Excel files, with images, this kind of stuff, chances are you want to use S3. You can even host static websites in S3. So it's really powerful solution. Again, I am polling the static, the S3 dependency, sorry. I'm creating a configuration with couple of the matching configuration properties. I am using the AWS S3 prefix. That's completely optional. In configuration, it will look something like this. And then in order to upload a file, I am again initializing the client. As you see, it's really consistent, the AWS SDK. So initializing the client from simple image service to S3 client is almost identical. Just the S3 client and before was SES client, so almost identical. When you do like so here in the save method, there are a couple of things. The method parameter type is completed file upload. That's a type that you can bind to a controller parameter. And that's typically what you will use to bind when you receive a form which uploaded a file, right? So you have like a form which uploads like a user picture. So you will bind it to this object. This object has several methods that will allow you to retrieve like the image bytes, like I'm showing down here, also the image file, etc., etc. You can even extract a file metadata. So if you are like uploading like an MP3 file, you should be able to access the MP3 metadata directly from this object. If you want your file to be public, you probably will want to use the access control list capabilities. So you can, I am highlighting there that I am using ACL. Yeah, you can basically tell, yeah, this file should be, maybe it's a picture that you want to be publicly accessible. So you set it up with public reader. The latest service that I want to discuss with you is Amazon Cognito, and arguably is one of the services that is gonna save you more time, more development time. So more often than not, we are reinventing the wheel, and we are in every app that we do, we have to code like the user registration logic, user login logic. The users, we need to support for them to change the password. We need to support a welcome email. We need to support a reset password email. Maybe then later on the line, we want to support multi-factor authentication. And as you see, that's a lot of logic that is probably not the problem that you are solving for your users, right? So maybe you have like a software as a service solution, and your what you are offering, your value proposition is not like being the best in coding, again, registration forms and login forms. So Amazon Cognito allows you to create user pools. It allows you to have like custom registration forms where you can upload like your company logo, so users don't know that they are using Cognito. That's completely transparent to them. And the best thing is AWS Cognito is OAuth 2 compliant and supports OpenID Connect. So OpenID Connect is a superset on top of OAuth 2, which allow us to deal with authentication. We are, I'm going to show you how to set up an authorization code grant type with Micronaut and AWS Cognito. Basically, the app is going to do what I saw in this GIF. Basically, there will be so it will repeat itself, but basically, there is a home page. You are not logged in. You click a link. You are redirected to. I am showing there. You see, there is a custom domain, so the user doesn't even know that they are in incognito. The user is going to enter their credentials incognito. You don't have to. You never see their credentials. Basically, Cognito is going to send us a callback with a code. We are going to exchange that code for a signed JWT, which is going to contain like an identifier for the user. We could actually even use that identifier to exchange that for a temporal set of access key ID and secret for the user. So we could have functionality such as an application which has like a different bucket per user, so that each user can have like their files in their own S3 bucket, and we could have like access to that. There are multiple ideas that you can you could power with Cognito, and then what I'm showing here as well is we have a logout button which will basically log out the user. When we receive so this is the flow. Let me go through it together again. So when the user visits like a URL that is unauthorized to visit, he will be redirected to the authorization endpoint. That typically will display a user form where the user enters his credentials. Cognito will validate the credentials. So Cognito here in this slide will be on the right side. He will be the OpenID provider. He will validate the credentials. He will send us a callback. We will receive the callback. We will take the code that we received in the callback, and we will exchange it in the token endpoint for a JWT token, for a JSON Web Token, which will be signed by Cognito. Here, since we have a secure channel, we don't even need to validate the signature. But if we wanted to validate the signature, Micronaut by default will attempt to validate the signature using the public JSON Web Keys set that the Cognito exposes in a public endpoint. Then you will go through a login success handler. So this can be whatever you want. By default, we in the samples we are using, typically we are displaying like we are generating a new token signed with our own private key, and we are saving that token in a cookie. Then since browser, whenever you send a request, they will send the cookies. We will validate the cookie, which will contain a JWT and authenticate the user. So when the JWT that we signed expires, then the user will be logged out from the application. What do you need to put in your application to do this? So you have to put like the Micronaut JWT dependency, which has a transitive dependency to the Micronaut security. Then you'll have to add the Micronaut security as an annotation processor dependency. You will need to do that because we have a couple of annotation processors to allow you to use annotations such as permit all from JavaX security, permit all annotation, or the roles allowed annotation. Then you will need to use also to include the Micronaut security auth2 dependency in your configuration, not really related to auth2. This is mostly related to what happened when we get like a token. So we turn on security with Micronaut security enabled true. We turn on JWT module with Micronaut security token JWT enabled true. We turn on a JWT cookie. That means that we will save the JWT by default in a cookie when a successful login takes place. We are setting here a secret-based signature. So this, we out of the box come with a generator. It's really easy in Micronaut to use like a more secure signature by using a JWK, so with both with elliptic curve or also with RSA. So those capabilities are there, and probably in production you will use those. And just add like a secret generator here just for reducing complexity of the presentation. We are enabling the logout endpoint, and we are allowing get request in the logout endpoint. By default, the logout endpoint allows only post request. If you want to allow get request, you have to turn it on as well. You will create a user pool, and from the user pool, you will need to take a couple of things that you will use later when you configure your Micronaut application. One is going to be the pool ID, and the other one is going to be what Cognito calls the app client ID and the app client secret. Those are going to be the OAuth client ID and the OAuth client secret that will be present in all of these providers. So Cognito is in the space of Okta, Keycloak, Auth0 is an application along those lines. Then in your app, you will turn on OAuth2. You can have multiple OAuth2 clients. So the clients will be qualified with a name. Here I'm using Cognito. That's completely optional. You could use Sergio if you wanted to. You supply the client ID, the client secret that you took, and then the issuer URL that will be in the form of HTTPS, Cognito, IDP, your region, Amazon, AWS.com, and the pool ID. So if you are using a different region, you will need to replace, of course, here, US one. Cognito will expose a well-known OpenID configuration endpoint, which will allow Micronaut to configure itself, basically, to work against Cognito. So from your point of view, from a user point of view, you don't need to do anything. Behind the on the background, when you start the application, Micronaut is configuring himself by using that endpoint. So then to render this HTML page that we're using, so in Micronaut expects in a controller to receive JSON and to respond to JSON, but you can render HTML as well. And we have a views module, and we have different view runtimes, such as Timeleaf or FreeMaker, Velocity. So there are several options that you can use. That depends of what you prefer, what your team is more comfortable with. In a controller, when you are using the views module, you typically will tell with the @view annotation which view do you want to render, and you can supply a model that you can basically populate in your template. We have another thing called view model processors, which you will use when some of the attributes in your templates appear in multiple pages. So you don't want to return them in all the controllers, but you want to be them present in every view. So in order to, one of these, for example, is we have, I believe it's called security view model processor, which will basically inject this security object in your views that you can render. So here I have a simple Timeleaf page, which when the user is logged in, which means the security model entry exists, we will display his email address. When he's not, we will display user anonymous. The value that you enter in the configuration, so here in configuration, I use Cognito as my auth2 client name. That will mean that a couple of endpoints will be configured for you. One of them will be the auth login Cognito, which I display here in the bottom. So the name that you use there will matter to create those endpoints. So choose a name that you are happy with. You will need also to specify a couple of URLs in AWS Cognito so that basically to whitelist those URLs for sending callbacks. Cognito will allow you to use for those callbacks for development localhost, but I think when you are in production, you have to use an HTTP address. They will not allow you to use just a plain HTTP, only for localhost for development, so you can test this out. Same for logout. Typically logout in this scenario, since we are not saving any state, the only thing that we have is a cookie with a JSON web token. Logging out a user from a Micronaut application in this case normally means only removing the cookie. So pretty simple endpoint. We have a couple of other things that I am not going to talk today about. We'll probably cover in the near future through maybe additional webinars or Micronaut guides. One of them is the discovery services using Route 53 capabilities. We are also really excited about Micronaut data and how well it plays with whole persistent layer of AWS, so all the RDS solutions. Especially excited about Aurora and Aurora serverless. That's something that I'm really want to get advantage of. And then we have also already support for creating Alexa skills, deploy them as AWS Lambdas using our AWS configuration module. So I have one last slide before going into questions with a couple of resources. So we are using Gitter for our community chat. So if you have any questions or you want to hang up with people using Micronaut and members of the team, we are often there. Just visit gitter.im.micronaut framework. It has it's free. Has clients for almost any platform. So yeah, visit that. I am proud of. I think the Micronaut documentation is quite good actually, and we are proud of it. And it's under docs.micronaut.io. And then we have a lot of step-by-step tutorials of doing like things with a Micronaut application. For example, we have a step-by-step tutorial about creating a Lambda using that function bean. We have a step-by-step tutorial about deploying an app to Elastic Beanstalk. So a couple of things that we mentioned today. If you like tutorials that guide you click by click, you will find them there. That's an excellent way also about learning at your own pace about the framework. Then we have a frequently asked questions in the website. The GitHub organization is github.com/Micronaut projects. The core of the framework is in the Micronaut core repo. You will see if there are multiple repos for each of the different pieces. So for example, there is a Micronaut AWS for the Amazon Web Services. We have a repo also with additional samples apart from the guides. And also we have under objectcomputing.com /products /Micronaut. So Object Computing is the company which is sponsoring the development of Micronaut. We have a lot of information there about blog posts, training, webinars, or any other solution that we can do for you for Micronaut, such as custom development. We do like team enhancement where someone from our team will work with your team together, or completely we can develop a Micronaut solution for you from zero. If you have any doubts, you can of course contact us via email or via Twitter or whatever medium you prefer. So yeah, again, thanks everyone for joining. Thanks a lot to you, Stefano, for joining us as well. If anyone is going to reinvent, make sure you visit Stefano's talk. Yeah, thank you.
Thank you all.
Thanks, everyone.